Hi there and welcome to the screencast. Tonight I'm going to do some sample problems for what you may expect to see on tomorrow's brief quiz on conditional statements. First of all, I'd expect you to know De Morgan's laws. And De Morgan's laws state that, um, can be written like this. Not A or B is basically the equivalent of not A and not B. And likewise, not A and B is the equivalent of not A or not B. So essentially, when you distribute a not across an and or statement, it reverses or changes the or to an and vice versa. So that's an important one to know. Um, Regarding actually evaluating Boolean conditions, um, here are some examples of what you might see tomorrow. In the first one, I have not A or B. Of course, by De Morgan's law, that's the equivalent of not A and not B. But if you just wanted to evaluate it the way it is, the order that you would evaluate it is you would do the parentheses first. So you have A or B. A or B means true or true. True or true is true. As a matter of fact, true and true is true as well. So not true is going to result in false. All right. In the next one, we have A is equal to B, or A is equal to C, and D is less than E, or not A, and X is equal to 6. So here it's important to notice that not takes precedence over the relational operators, being the equals and the less than. And then after that, at the very bottom of the order of operations, you execute the and then lowest of all is going to be or. So how does that apply here? Well, the first thing I'm going to do is the not takes the highest precedence, so I'm going to say not A. So not A, let's see, A is true, so that means not A is going to be false. So let's see if I can, all right, so I'm going to have, and you know what, I'm going to have false for not A. And actually, I have this in NetBeans, so let me do it in NetBeans as well. So not A is going to result in false. Okay, then I'm going to do the relational operators from left to right. So A is equal to B. Well, A and B are both true, so A being equal to B is going to be true. A is equal to C. Okay, A is true, C is false, so that would be false. D is less than E, so 1.2 is indeed less than 1.4, so that's going to be true. And then lastly, the X is equal to 6. That's false. And now I'm going to go through and do the ands before I do the ors. So false and true. Well, if I have one true and one false, if even just one of the two is false, the whole thing's going to be false. So that means I'm going to replace that with false. And then here, false and false. Well, that's going to be false. False or false is also false. So if you have two falses together, either by an and or, you always get false. And now I'm going to finally do the true or false from left to right. I'm doing the ors the very last of all. They take the absolute, have the lowest precedence. So true or false is going to give me true. And then true or false again is going to give me true. So this whole thing is going to result in true. All right, next one. Not A and B and C, or Z is less than Y and X is less than or equal to Y. All right, so A and B and C. So the first of the thing, I'm going to do parentheses. So A and B and C, I'm going to go from left to right, and it turns out I have true and false. So the A and B becomes true. True and false is false. Then now I have what comes next. The not takes precedence over the relational operators and the ors. So not false is going to be true. And now I'm going to do the z is greater than y and x is less than or equal to y because the relational operators precedence over the or and the and. So z is greater than y. That is true. And x is less than or equal to y. That is also true. All right, and now I have true or true and true. Well, that whole thing is going to be true. It wouldn't matter if it was true or true or true, or true and true and true. Anytime you have two trues, you're going to do a comparison, and two trues result in a true statement. So, but if I want to do it one at a time, I'm going to do the and one first. That gives me true. So true or true is of course true. All right, so then the last one here, I'm going to do, let's see, I'm going to do what's in parentheses first. So what's in parentheses is going to be the A and not B and C. So in of what's inside the parentheses, the not takes precedence over the and. So I'm going to have not B. Not B is going to be false. So, okay, and now I have A and false and C. So I'm going to go from left to right. It's going to be true and false. True and false. One true, one false results in false. And false is going to give me a false. Okay, now the next thing I'm going to do is the not. So not false is going to give me true. And now I have true and not p dot equals yes. Okay, so I'm going to do the not p dot equals yes. So p dot equals yes. Let's see, is p equal to yes? Yes, it is. So that's true. So not true is going to be false. All right, now I'm going to do the let's see, I'm going to do the modulus division, so which takes precedence over the comparators, the equals. So y percent 2 is 6% 2. So that is what? That's 0. Is 0 equal to 3? No, it's not. So that's going to be false. And now I'm going to do the and before the or. True and false is false. And false or false is false. So the whole thing is going to be false. So the important thing to know here, you need to know the truth tables. You need to know the fact that for or, a true or true is going to give you true. A true or false gives you true. And a false or true is true. The only time you get false with an or statement is if both are false. Okay, now with the and situation, you get false 3 out of 4 times instead of true out of 3 out of 4 times. So with false, you get, so let me just replace this quickly. Let's see, can I do edit, replace? Let's see, where is it? I'm going to replace that with and. Okay, so with and, you're going to get, when you have the differences, when you have one true and one false, with and, you get false, with or, you get true. Okay, so you should be able to evaluate statements like that. And then lastly, you should be able to write a simple logic method like the kind that are found in Coding Bat. So here's one that's called max mod 5. And it says given two values, return whichever value is larger. However, if the two values have the same remainder when divided by 5, return the smaller value. However, in all cases, if the two values are the same, return 0. So I'm going to write, you can write this a variety of ways. I'm going to handle the in all cases statement first. So I'm going to say if A is equal to B, okay, then we return 0. All right, so then it says if the two values have the same remainder when divided by 5, return the smaller value. So that's the next case that I'm going to check for. So I'm going to say else if A percent 5 equals B percent 5. Then I'm going to return whatever, the smaller value. So I'm going to say if A less than B, return A. That would be the case where A is smaller, and then otherwise return B. All right, so that takes care of that one. And you may say, well, what if they're equal to each other? If they're equal to each other, this code is never going to execute because it would have ended right up here in the A equal B case. Okay, so then lastly, I'm going to handle the situation where I'm going to return the smaller value. So I will say else, the general case where I'm going to return, oh no, I'm sorry, I'm going to return the larger value. So I'm going to say if A greater than B, then I return A. Otherwise I return B. Alright, so let's see if this works. Okay, good. I got it all correct. Alright, so let me see if, well, if you look up the solution, you'll find there's a much simpler way. However, I think the logic of it is a little bit easier when you kind of divide it. You make it lengthy, but the logic simpler. Incidentally, I actually wouldn't have needed any curly braces here because after each condition, there's only one statement. So I can take out all of the curly braces and it should work. So let's see. Let's see. Let's see, or maybe not. Oh, okay. So I think, yeah, no, I'm sorry. I was a little premature. I do need at least some of the curly braces. I need those curly braces because I actually have two statements here. I have a condition and I have a return statement, and I also need these curly braces because I have two statements. All right, let's see if that's better. Yeah, that's right. Okay, however, I don't need them after the if A is less than B, return A, because there's only a single statement right after the condition, that being return A. Also don't need it for right here, and I don't need it right here because there's only one statement following the condition that is applicable to it. All right, so the secret sentence tonight is going to be Volkswagen halts all sales of diesel models in the 2016 model year. So that's Volkswagen halts all sales of diesel. It's diesel. Well, what did I just say? Volkswagen halts all sale of its diesel products in the 2016 model year. Okay, hope this helped. And do a few coding bat, logic 1 practice problems, a few of the Boolean logic issues. Know how to write a simple method that like in coding bat, that returns a value, and that'll do it. Cheers.